Today I'll show you how to use Taylor and Maclaurin series on your graphing calculator. So let's get started. Alright, why do we use Taylor and Maclaurin series to start with? We use them because those are in polynomial form and they are a lot easier to handle most of the time. One application may be to evaluate difficult integrals for certain functions, but if I can approximate a given really difficult function by a polynomial, I can actually integrate it a lot easily. Another is if I want to understand asymptotic behavior or behavior around certain numbers, the polynomials are easier to handle. And also, I can use them to solve differential equations. So, they're very, very handy tools. So, if somebody says, okay, what's the Taylor series approximation of a function at around a, so that that polynomial that I obtain will behave very similar to my function around that point. It's given by this formula. This is the nth derivative, so you take the 0th derivative first and second, third, fourth, all the way to n. And then as n goes to infinity. So you can write it as a polynomial. Now, that's called Taylor series approximation. When you take a equals 0 in that formula, you get Maclaurin series approximation. So Maclaurin actually is just a special case of Taylor. So let's look at a couple of things. For example, somebody may ask you, find the Maclaurin series approximation of f of x equals e to the x and its radius of convergence. So how would you do that by hand? So you can write down what f of 0 is, f prime of 0 is, f double prime of 0 is, and as you know, the derivatives of e to the x are always e to the x, and e to the 0th power is 1. So e's will disappear. All you're going to have is 1 plus x, x squared over 2 factorial, x cubed over 3 factorial, and so forth. Now, in terms of radius of convergence, remember what you need to do. You need to look at the absolute value of an plus 1 divided by an, and then you get this, and now look at it, what it will converge to. It will converge to 0, and then you know that that's less than 1. So by ratio test, you can say the radius of convergence is infinity. But what's important is, if somebody asks you, find second, third, or fourth order, or some order of Maclaurin polynomial of a function, and then graph it, or look at the behavior, this is what you do. For example, if they ask you third order Maclaurin, and your f of x is e to the x, all you have to do is just go 0, 1, 2, 3. So you have a polynomial that looks just like this. Now, if you want to see the behavior of that polynomial around 0, this is what you can do. You can actually plot it. So let's enter e to the x right here. This is my function itself. And then I'll enter my polynomial. 1 plus x, 1 plus x, and then plus x squared over 2. X squared over 2 plus x cubed over 3 factorial, which is 6. X cubed over 6. Alright. Now, you can get the factorial from the catalog. So, let's look at the Zoom standard window of that. So, if I have Zoom, and I go Zoom standard, oops, that's number 6, and look at it, oops, I have that stat plot that's already in there. So let's turn off the stat plots and let's turn off the grids so that we can see a little better. So this is a good exercise. So if you have something already built in, that will just display right away, and then you want to just take it off. I will also take the grids off. You can go and format. So let's look at format. Grid on, you see that third line? So I'm going to turn it off. And then let's quit. And let's graph. Here's my e to the x. And here's my polynomial. And at around 0, so I can actually zoom in. Let me zoom box this around 0. So let's go to the left, up a little bit, and enter, down, and to the right. And around 0, this is what it looks like, the two functions. Here's e to the x. Excuse me. Let me make it a little bit darker so that we can see it. Here's the darker version. Let's graph it. You see around 0, you hardly see the difference between these two functions. So the first one was drawn, and the second one was almost on top of it, around 0. So you can visually see that with the graph feature of your graphing calculator.